Number 19. High-speed stroboscopic photographs show that the head of a 200-gram golf club is traveling at 55 meters per second just before it strikes a 46-gram golf ball at rest on a tee. After the collision, the club head travels in the same direction at 40 meters per second. Find the speed of the golf ball just after the impact. So we can draw ourselves a little picture here. Basically, it's just said that there's this golf club that has just been swung at a golf ball sitting on a tee. The mass of, I'm just going to say denoted as capital M, the mass of the golf club is 0.2 kilograms. 0.2 kilograms. 200 kilograms. And the velocity, the initial velocity of the golf club is 55 meters per second before it hits the golf ball. Now, the initial mass, or the mass of the golf ball, we're going to know as little m, is equal to 0.046 kilograms. It also gives us that the initial velocity of this is 0 meters per second because it says it was at rest on the tee. Yeah. So it gives us one more piece of information, that the final velocity of this golf club is 40 meters per second. And it's asking for the speed of the golf ball after the impact. So that will give us, after means it's going to be the final velocity here, and the golf ball is referring to v2. The speed of the golf ball is referring to v2, so therefore v2f is our unknown quantity. So this seems like this is a conservation of momentum problem. The conservation of momentum is maintained unless there is an external force that acts upon the system. Do we see any external forces on this golf ball swinging at the golf club swinging at the golf ball? No, we don't. So momentum, we can assume that momentum is conserved from this golf club to the golf ball. So we can set up the equation for the conservation of momentum. M v1 0 plus M v2 0 is equal to M v1 f plus M v2 f. So this is our unknown quantity. We can just plug in the numbers that we have into this equation. 0.200 kilograms times the initial velocity of this golf club, 55 meters per second, plus the mass of the golf ball, which is 0.046 kilograms, times the initial velocity of this, which is 0 meters per second. We can cancel this out. On the other side, again, 0.200 kilograms, the mass of the golf club. And the final velocity of the golf club, which is given to us, is, as it says right here, 40 meters per second. And finally, the mass of the golf ball, 0.046 kilograms. Multiplied by V2F, our unknown quantity. Now, this is fairly straightforward algebra from here. So if we simplify this, 11 kilograms times meters per second is equal to 8 kilograms times meters per second plus 0.046 kilograms times V2F. We can subtract these this quantity on the other side. 0.046 V2F is equal to 3 kilograms times meters per second. And if we divide on both sides, we get approximately 65, kilograms here, 65 meters per second.